So let's look at a midsegment of a triangle. Whenever we draw a midsegment, it's going to be a segment connecting the midpoints of two sides of the triangle. So on this side I have a midpoint on the left, midpoint on the right. We draw them, we get our midsegment. Now the important things we need to know about a midsegment are the midsegment is half the length of its parallel side. So it always hits two sides at their midpoint. It's that third side it's parallel to, and it's going to be half the length. So we have down here is two examples where we have three midsegments drawn, and we look at the idea of half the length and the parallel side. So over here on the left, I've drawn FD is a midsegment with AC. We have DE is a midsegment with AB, and FE is a midsegment with BC. So using that, FE we would say is 1/2 the length of BC. We could also say, because we're cutting BC up at midpoints, that FE is the same as BD and DC, which we can see these little 3 marks, 3 marks, 3 marks, they also match. Same thing with FD. FD is 1/2 the length of AC. We could also say FD is equal to AE and EC. We could also look and have smaller triangles here. We have 1, 2, 3, 4 different triangles, and all of those triangles are congruent by side, side, side. We have a marking of each in each one, this one being rotated around, but there's that congruence there that allows us to also go through and start to match corresponding parts that exist. Now, other diagram, we're looking at parallel sides. So FE is parallel to BC, FD, AC, and then DE, AB. We can't prove congruence by the parallel alone, but we can start to see we would have some angles that match. These 3 angles would all be corresponding angles by our parallel lines, as well as this angle here would be congruent because that gives us kind of an alternate interior working through them. They're all corresponding within the congruences we have. We can maybe go through and start to solve for angles as well. So let's start with some sides. L, M, and N are midpoints within our triangle. We know that PR is 46, PQ is 40, and LN is 17. So let's find some different values. We need to find LM first. LM, this side, is related to the 46 because it's parallel to PR. Now LM is half the side, so LM should be 23. That 23 on LM has nothing to do with the 40 nor the 17. They only relate to their parallel sides. So MN is going to be half of the 40, so that'll be 20 units. QR, which is this whole side here, is going to be 17 times 2, because we double it to give 34. And then when we get to MR, because the whole thing is 34, each of its pieces are 17, since M is a midpoint, that'll be 17. We go to the next one. We need to find the value of x. We are not going to set those two values equal because they're not equivalent. One of them is a side, the other is a midsegment. It's half the length of the side. So one option we could go is 7x equals 1/2 17x minus 18, but I probably wouldn't solve it that way because I'm going to take half of 17. It doesn't mean we'll never get an answer with a fraction, but why bring up a fraction in the beginning when we can kind of simplify further through the process? So instead, let's go 2 times 7x equals 17x minus 18. Or we double the midsegment to set it equal to the side. That gives us 14x equals 17x minus 18. We then get a negative 3x equals negative 18, and x comes out to be 6. We should check our answer. We go up, we substitute 6 in for x on the 7x, we get 42. If we substitute 6 into the 17x minus 18, we get 17 times 6 is 102, minus 18 is 84. So we look, it is actually double the midsegment in length. So a good way to check our answer. So we go through and solve some more here. We have BE is what we're looking for. We know CB, which is the whole thing, is 11x minus 25. CE is the part. So I want to double CE and set it equal to CB because that is the relationship between the midpoint and those segments. So we're going to go 2 times 4x plus 1 equals 11x minus 25. Gives us 8x plus 2 equals 11x minus 25. Subtracting the 8x from both sides, we get a 3x. If I add the 25 to both sides, I get a 27, and we get x equals 9. But we're looking for BE. Now, BE is either half of CB, the whole thing, or it's equivalent to CE. So either one would work. If we did the 4x plus 1, we would do 4 times 9 plus 1. That's 36 or 37. That would work. Or we could do the 11 times 9 is 99, minus 25 is 74, which is the whole side of BC or CB. We take half of that and also get 37. So BE in either case is 37 units. Next we need to find RT. So I'm going to go 2 times 15x minus 17, or 2 times PQ, is equal to RT, which was 23x minus 6. That gives us 30x minus 34 equals 23x minus 6. I'm going to subtract 23x from both sides. I get 7x. We then add 34. We get 28. And that gets us to x equals 4. From there, because I'm looking for RT, we're going to go 23 times 4 minus 6. Looks like 92 minus 6, and we get 84. No, that'd be 86. We should check our answer. If I came over here and did 4 times 15, that'd be 60. Minus 17 is 43, which we double to get to the side, and it would also be 46. So good way to check our answer. The next one, we need to use the information we have within the midsegments to eventually find the perimeter of the two triangles, JKL and MNO. Now I know MN and I know NO. We need to find MO. So I can take the 6x minus 1 and the 13x minus 10. I'm going to do MO equals, we'll do 2 times MO equals KL. I don't want to take half of the longer side. So that's 2 times 6x minus 1 equals 13x minus 10. 12x minus 2 is what we have on the right side, equals 13x minus 10. Subtract 12x over and then add the 10 over, we get 8 equals x. Put that back in and we get 8 times 6 is 48, minus 1 is 47. Then if we did 8 times 13, that is a 104, minus 10, that is 94. Quick look there, 47 times 2 is 94, so we have the right idea. So now for our perimeter, right, perimeter of triangle, do the small one first, MNO. We're just going to add the sides, 47, 49, and 42. And that comes out to be 138. Then when it goes to the perimeter of triangle JKL, well, I have the 94. To get to JK, I'm going to double 42, which is 84. And to get to KL, I'm going to double 49, which is 98. So we're going to 94 plus 84 plus 98 gives us 276. Now, are those two answers related? If we look, 138 times 2 is in fact 276, and because we're doubling the midsegments to get to the sides, the perimeter should be double of the smaller triangle. And it did work. All right, now find the measures of the angles down here on the bottom left. Now, we have to be careful here. angles 1 and 2 have to do with the 127 degrees. Angles 4 and 5 have to do with the 59 degrees. They're related to it that way. Once I get those, then I'll find angle 3. So start off, let's find angle 2 because it's a linear pair to the 127. So we'll do 180 minus 127. And that gives us 53. So 53. So that's angle 2. Now if that is 53, we know angle 1 is the same thing because 1 and 2 are corresponding angles with our parallel lines. They're in the same location, so we have 53 there as well. We go down to the next one with 4 and 5. I know angle 4 is also 59 degrees because it's corresponding to the 59 degrees. And then 4 and 5 being a linear pair, 180 minus 59 gives me 121. So now for the last one, we can use the fact that angle 1 is 53 to do 53, 59, and angle 3 to add to 180, or 53, 59, and angle 3 add to 180. They're the same triangle, it's just different. It's just scaled a little bit different. They're similar, which is something we talk about later. So 53 and 59 gives us 112. We subtract that from 180, and we get 68 degrees for angle 3. For our last problem, we look again, these are corresponding angles, so we know they're equal. We're going to go 9x plus 2 equals 15x minus 52. Subtract 9x over, I get 6x. I'm going to then add 52, we get 54, so x equals 9. We then substitute that in. We want CBF, which is this angle, which they're really the same. But the measure of angle CBF is going to be 9 times 9 plus 2, which is 81 plus 2, or 83 degrees.